Hello students, welcome to all of you. Myself is V.S. Dixit. I teach in Department of Computer Science, RST College, University of Delhi. As all of you are aware that due to the pandemic of COVID-19, the university had directed all the teachers to take the classes from home on the precautionary measure, and those material will be uploaded on the website and you can refer those e-material from the college website. And today I am going to discuss the concept of relational algebra and relational calculus. And before that, what in the previous classes I discussed, I just want to introduce about that. I discussed about the concept of databases, various aspects of the databases, then what is the difference between the data, information and knowledge, then various types of data models, in which I discussed about the hierarchical model, then I discussed about the network model, relational model, object data model. After that we discussed about the DBMS, then various types of DBMS we discussed. Then we discussed about the relational database management system and various properties of the relational database management system in the form of CORD's 12 rules. And I told you that any relational database management system will be an ideal relational database management system if that fulfills all the properties of CORDs. Then I discussed about the data independence, various aspects of data independence and the difference between the logical data independence and physical data independence in the form of three-level architecture of the DBMS. Then I discussed about the database and database system. After that, what are the different actors who while working on the database, for example casual user, parametric or navy users, then DBA, then database managers. And then I also discussed about the responsibilities of DBA, responsibilities of the database managers, then responsibilities of casual users, navy users. Then what are the different architecture, one single layer architecture, two-tier architecture. I discussed about the three-tier architecture. Then what is the architecture of a database system in detail I discussed, in which I discussed about the DDL compiler, DDL system catalog, and all these terminologies were discussed over that. After that, what are the advantages and disadvantages of DBMS? Then I discussed about the physical modeling or conceptual modeling. All of you know that the conceptual modeling is done through the ER diagram. And in the ER diagram, we discussed about the various symbols used while designing or conceptualize our database. After that, we discussed about the specialization, generalization, what is the difference between the specialization and generalization, then various categories, union, different type of terminologies, aggregation, and all these points were discussed over there. Then I told you that how to convert from conceptual modeling to the logical modeling. And after that I discussed about the structured query language and construct of the structured query language and various concepts of queries like subqueries, like correlated subqueries, then various functions, character functions, date functions, number functions. There was a discussion in a detail. Today I am going to discuss about the relational algebra and relational calculus. Relational algebra form the basis for the relational algebra, form the basis for the SQL. Relational calculus form the basis for the SQL. And there is a concept of relational completeness. So first of all, I will discuss relational completeness. What is relational completeness? Relational completeness is a basic measure of the expressive capability of a language. Any language is said to be relationally complete if and only if it is as powerful as relational algebra and relational calculus, if we talk in terms of database. So we can say that SQL is a relationally complete language. Why relationally complete language? Because Always relational algebra and relational calculus form the basis for the SQL, which is practically implementable. Now, relational algebra. Relational algebra is a procedural language, or we can say relational algebra is a procedural query language which takes instances of a relations as input and yields instances of relations as output. It uses operators to perform queries. Meaning is that whenever in relational algebra we apply any operator on any relation, it always produce some output in form of relations. And again, that output which is in the form of relations can be input for another relations. And in this way, we can say that relational algebra is a procedural relational query language. The relational algebra is proposed by E.F. Codd in 1970s. And always in relational algebra, whatever operators we are using, either those operators are unary or those operators are binary operators. So we use various operators in relational algebra while writing queries for a database. For example, select, two very important operators, selection operator and projection operator. Selection operator is a criteria which we apply on our query. This is same as where clause in SQL, and we represent this select operator as sigma. And the syntax of this is sigma p and r. Sigma subscript may p r, where r is the relation, sigma is the select operator, and p is the predicate. And the select operator select tuples that satisfies a given condition, where this predicate which is also known as propositional logic, which consists of logical operators, for examples and, or, and not, and various relational operators. What are the relational operators we can use? Less than, greater than, not equal to, greater or equal to, less than equal to. So these various operators we can use while we are giving predicate to our condition. Then second operator is project operator. This project operator is same as select command in SQL, and we always denote it through pi. And what is the syntax? What is the notation for this? So we can write pi in subscript attributes name a1, a2, an, and this pi operator is applied on relation R. So for example, if we are having a relation or we are having a table employee in which the various attributes are there: employee number, employee name, salary, department number, department name, commission. In organization, employees are there who are having various attributes. Then if I want to write a query to retrieve the names of employees, so what you will write? You will write pi, then in subscript you will write ename, then you will apply on relation in bracket employee. This will retrieve all the names of the employee. Here, if you want to apply the condition with this project operator, then you will write pi, in subscript ename, then relation R. Then you can write after pi, sigma, suppose condition is that salary should be less than 10,000. So sigma in subscript, salary should be less than 10,000. So in this way you can make the combination of pi and project and select operator. So this is the same as in SQL, that select attributes name, then from table and where condition. So here in relational algebra, select is same as pi and where is same as in relational algebra sigma. Sigma is the condition, which is the select operator, and pi is the project operator. Both are unary operators, right? Then third operator is the union operator. Basically three sets operators are there: union operators, intersection operators, set intersection, and set minus operator. Union operators. Union operator eliminates all the duplicate tuple. When you apply, and this is a remind you, this is the basic operator, a binary operator. Union is always a binary operator, and suppose there are two relations, relation R1 and relation R2. Then I will write the notation R1 union R2. For example, suppose we have to retrieve the employee name from two tables. One is employee and another one is employee 1. Then how I will write the query? I will write the query pi in subscript e name, in bracket I will write employee union employee 1. Now what does this union operator do? So this union operator contains all the tuple that are either in R or S, or both in R and S. And as I already stated, that it eliminates the duplicate tuples. Then another operator is intersection operator. The intersection operator, for example, again I am telling, if there are two relations R1 and R2, and if I am writing the notation R1 intersection R2, so it means that it will retrieve those tuples which are common in both the relations R1 and R2. Then third one is minus operator, R1 minus R2. If two relations are given R1 and R2, so R1 minus R2, so we say that R1 minus R2 will retrieve those tuples of R1 in which the tuples of S is not there. So this is the result of R minus S. Then whenever you are going to apply set operators, so there are mandatory conditions for applying the set operators. The first one is, if two relations R1 and R2 is there, then R1 and R2 must have the attributes of the same number. And second one is both will have the same number of attributes and their domain should be same. So this is in combined is known as arity of a relation. So if two relations R1 and R2 is there, if you want to apply the set operators, so always this condition should be satisfied. Now there are another operators in which the Cartesian product is there, and we denote the Cartesian product with the cross symbol. And in the set theory, because the relational algebra is basically derived from the set theory, from the concept of set theory. So you are aware in the set theory that if two relations are there and R1 cross R2, so it will give all ordered pairs of values in set theory. In the same manner, when you are using the Cartesian product between two relations R1 and R2, R1 cross R2, then it is used to combine each row in one table with each row in another table, and it is also known as cross product, and which is denoted as R cross S. When you will apply any condition on the Cartesian product, then that will become a join. So I will discuss join operator later on. Before discussing that, there is another operator, that is the rename operator. So in relational algebra, as in SQL also, you can do that by using the aliases. In relational algebra, the rename operator is used to name the attributes and relations. Then how it will be represented? It will be represented through symbol row. For example, if I am having a relation employee, and if I want to rename it as a employee 1, so how will I write? I will write row in bracket employee comma employee 1. Then the employee relation which is already existing, that will be renamed as employee 1. So in the same manner, we can rename our attributes also. So as I earlier stated, join operator. So in the join operator, we always apply the condition on the Cartesian product, right? So that is becomes the join. And formally, if I want to define the join, so a join operation combines related tuples from different relations if and only if a given join condition is satisfied. If a given join condition is satisfied, and always this is known, this can be represented as like this symbol, like dumbbell, horizontal dumbbell. Join can be categorized in various categories. One is natural join, another one is theta join, then outer join. Natural join, when we are joining two relations, and if they have the same attribute on both the side in the join condition, and that is with the equal operator, that is basically the natural join. After that, or we can also say the equijoin if equal operator is there. In the theta of join, while we are imposing the conditions could be non-equi, matlab means that can be the relational operators, less than, greater than, in operator, matlab there can be various operators. So that is known as non-equi join. The third join category is very important, and that category is the outer join. Outer join is used to handle the missing information, and there are three categories of join. One is left outer join, another one is right outer join, and third one is full outer join. So where is the need of outer join? We have to understand this concept. So for example, we are having two relations. One relation is employee, in which various attributes are there. For example, employee number, employee name, salary, commission, joining date, hire, then department number. Another one is department, where the department number, department name and location, where a particular department is located. These two relations if we are having. In department table, there are 4 departments: department number 10, department number 20, department number 30, department number 40. And in employee table, there are only 3 departments, employees of only 3 departments: department number 10, 20 and 30. What does it mean? It means that for the department number 40, there is no employee if employee and department table related with each other. Right? So if in employee table there are 3 departments 10, 20 and 30, and in department table 10, 20 and 30 and 40, and if department number 40 is not having any employee, and if we are applying the join condition, equijoin condition over there, we will get only 3 rows. Why we will get only 3? We must get the 4 rows. So in the department number 40 there is no employee, so that is relating with the null row, so that becomes the null. So that's why we are getting only 3 rows tuples while we are applying the equijoin. So in the database, the most important aspect is there should not be any loss of information while you are applying any operator. So how to stop this loss of data? Through outer join we can do that. While we applying the join operation, when we give the condition on the join operation, I told you that in employee and department table, who is representing the table, who is representing the relationship? Department is representing the relationship, because in one department there can be more than one employee, but one employee cannot be in more than one department. So department is representing. So the common attribute department number, which is the key attribute, primary key attribute of the department table, and in employee that is the foreign key. And with the referential integrity, you know that every foreign key refers its primary key, foreign key refers its primary key, right? And one more thing, in parent table, always if any primary key attribute is there, the value of that would be not null as per the entity integrity. So when we apply the join condition, always the foreign key will be on the left side and the primary key will be on the right side. So if we are having 2 relations, employee and department, and if we are applying the condition, so we will write employee, then horizontal dumbbell sign, then department, and we will write employee department number equal to department number. Employee dot department number is equal to department dot employee number. Then this is the equijoin. Now to show the information, missing information, we will use the outer join. So here, which one is missing? The tuples in the employee table is missing, because department number 40 there is no employee. So if the left side relation or child relation is missing, then that will be the left outer join. So with the horizontal dumbbell, we will 2 parallel lines will be there along with the horizontal dumbbell, that is the left, on the left side, that is the left outer join. In the case if the parent table is deficient, right, and there is a chances of missing information while you are writing the query, then you will apply the right outer join. And in case, and that will be represented through the horizontal dumbbell, and from the right side 2 parallel lines. And if both the tables are missing, data in both the tables are missing, then you will use the 4th outer join. Now in the next class, I will discuss different problems of relational algebra and Along with that, I will tell you the different other aspects of relational algebra in the subsequent lectures. Thank you very much. Now I am going to discuss about the concept of relational calculus. So relational calculus can be categorized into two categories. One is tuple relational calculus and another one is domain relational calculus. And this relational calculus concept also forms the basis for the other programming SQL database programming languages like SQL. In always relational calculus uses the concept of logic, propositional logic or predicate calculus, and this is the non-procedural way to access the database. Why this is the non-procedural way to access the database? Because here how the things are going on, we don't have any concern about that. What we have to do with the database, it will give as a resultant. Whenever we write any relational calculus expression, it will give the what we want. But how to do that? From that point of view, there is no concern of relational calculus. That's why we can say that relational calculus is a non-procedural database query language. As I stated earlier, that can be categorized in tuple relational calculus and domain relational calculus. Tuple relational calculus was proposed by E.F. Codd in 1972, while domain relational calculus, in short form we call it as DRC also, and for the tuple relational calculus, that is known as TRC. So DRC was proposed by Lexcroix and Pierotti in the year 1977. The relational calculus takes its name from a branch of symbolic logic termed as predicate calculus. In predicate calculus, predicate is a truth valued function with arguments. What I told you that in predicate calculus, a predicate is a truth valued function with arguments. When we replace with values for the arguments, the function retrieves or function yields an expression that is called proposition, which will be either true or it will be false. How to represent the query? To express a query in relational calculus, we write like this: curly braces, then we write S, then bar, then we write the Fs. Where the S is set of all tuples such that the value of Fs is true. What I told you? In bracket S bar Fs, where S is the set of all tuples such that Fs is true. And if I want to write a query in tuple relational calculus as per the notation, so as I stated, suppose we are having a relation or employee. In employee, there are various attributes: employee number, name of the employee, then salary of the employee, then joining date of the employee, then commission of the employee, what commission he is getting, then department number of the, these are the various attributes in employee table. And if we write a query, if we write a query to retrieve the details of all those employees whose salary is greater than 50,000. So how to write? So we will write S. S is a tuple variable. S is what? Tuple variable which spans over all the attributes of a relation. So that is a tuple variable. So we write S. Then what is the name of our relation? The name of our relation is employee. In bracket we will write S. What is the condition? Where salary is greater than 50,000. So we will use the conjunctives. What are the logical connectives? The logical, because they are well defined formula. That is the formula. The formula is what? Formula is the expression. Expression is the combination of the different connectives or different, for example, or, and, not. These are the various connectives. So we will write and S dot salary is greater than 50,000. So in this way we will write. So first of all, you will have some relation. You will take a tuple variable. That tuple variable will span over all the relation. So for example, in employee table, we have taken a tuple variable S. So we are writing S bar, then name of the relation employee, bracket में tuple variable, and the condition is S dot salary is greater than 50,000. Now another query. Write a query in tuple relational calculus to retrieve the details of the department, all the details of the department where department number is 20. How to write this? Very simple. This time I am taking tuple variable will be another name, because tuple variable is a variable that can be of any name, S or T. So this time I am writing T, curly braces, T bar. After that we are writing the name of the relation, department, in bracket tuple variable T, and in query that is given that T dot what? Department number, DPTNO is equal to 20. Very simple. So in this way we can write the expression for tuple relation calculus. There are quantifiers which are used in logic when you that is the branch of the mathematics, and as I earlier stated that relational calculus is derived from the concept of logic. So there are the concept of quantifiers. So what are the quantifiers? For all. We denote this with the symbol V, and then this is for all, and then exist operator, there exist. So this is the for all quantifier and this is exist, and both of these are bound variables. Both of these are bound variables. So any tuple variable with for all and their exist condition is termed as bound variables. Or any tuple variable, remember this, any tuple variable without any for all and their exist condition is free variable. Now I will discuss the concept of domain relational calculus. So domain relational calculus is also derived from the concept of logic, but there is one difference between the tuple relational calculus. Here we will take the domain variable. In earlier tuple relational calculus, we will take the tuple variable which spans over all the attributes. Here we will take the domain variable which will correspond only to that particular variable. For example, if there are variables, there is a relation employee. In employee relation, if there are various attributes, employee number, employee name, salary, commission, joining date, right? So how many columns are there? 5 columns, attributes. So what are the variables? We will write A, B, C, D, E. These are the 5 variables. So these are the 5 domain variables. A will correspond to column A, first column. B will correspond to second column. C will correspond to third column. Fifth will correspond to E will correspond to fifth column. So there are total 5 domain variables. So what is the syntax? How we will write? So we can write like this. The syntax is this. Here domain variables d1, d2, dn, curly braces, dn, backslash, then function, bracket, in bracket, then attributes, domain variables. So this is the syntax. So in the same manner we can write the query in the case of domain relational calculus also. So suppose I want to write a query, very simple query. Same example I am taking, employee table. I want to write a query to retrieve the employee number, employee name and salary from the employee table where employee number is A5620, where employee number is A5620. So now how many columns? Employee number, employee name, salary, commission, joining date. Okay, these are the 5 attributes. So what are the domain variables? A, B. A will correspond to first column, B will correspond to second column, C will correspond to third column. Right? So how to write the query? I will write curly brace A, B, C. Select employee number, employee name and salary. Slash A correspond to employee number, B correspond to employee name and C corresponds to salary. Slash there exist E, F, right, the domain variables and what is the employee number? A equal to A5620. So in this way you can write the query for the domain relational calculus. Now another term, that is the safe expression. What is the safe expression? So all the queries we write in the domain relational calculus and tuple relational calculus, those queries are safe queries, right? And a safe, which is also known as safe expression. So we can define safe expression that safe expression is one that is guaranteed to yield a finite number of tuples as its results. Finite number of tuples as its results. So if I am writing an expression in tuple relational calculus like this, T, this is the tuple relational variable, slash not employee. what it will give? This expression will retrieve all the tuples in the database except the employee relation. So this is the unsafe. This is the unsafe expression. Again I am repeating, there is a tuple variable t bar. This is what? This is the not, boolean not, and there is a relation employee. So this particular expression in tuple relational calculus will retrieve all those tuples which are not the part of employee. For example, in database there are various relations: employee, department, project, supplier number, supplier, part, then shipped. There are various relations, and if you are applying this unsafe expression, you are writing this particular tuple relational expression, then it will retrieve all the tuples in the database except employee. So such type of expression is unsafe expression. That will always return the infinite number of rows. Right? So always remember, safe expression will return the finite number of rows and unsafe expression will return the infinite number of rows. So this is about the relational calculus. I am again summarizing that relational calculus is based on the logic, that is based on the predicate calculus. Then relational calculus is a non-procedural way of accessing the data. We can categorize the relational calculus into two categories. One is tuple relational calculus, TRC, and another one is domain relational calculus. In the tuple relational calculus, we take tuple variable which spans on all the attributes, right? And in domain relational calculus, we take the domain variable which corresponds to a particular column, right? While we writing the expression either in tuple relational or domain relational calculus, in both the case, while we are writing the expressions are in the expression, there will be formulas. Formulas will consist of various connectives, right? The connectives like Boolean operators and, or, and, not, right? Then various relational operators, less than, greater than, less or equal to, greater or equal to. Then I told you about the relational safe expression which will always yield the finite number of rows. Then I also give you the example of unsafe expression and remind you, unsafe expression always returns the infinite number of rows. So this is all about the relational calculus. In the subsequent lectures, I'll discuss various problems in relational calculus which will consist of tuple relational calculus and the domain relational calculus, and one textbook I'll refer for you, that is the database system by course, in which the concept of relational algebra and relational calculus is given. Another book is Navate. Navate is also a very good book, database system using the written by the Navate. That is also very good book, and you can study the relational calculus, tuple relational calculus and domain relational calculus in detail. In subsequent lectures, I'll again discuss the different problems of the relational calculus. Thank you very much.